Alright, so welcome to Class 3. We are covering FRC Programming. My name is Jared. I am a junior at Overlake, and I'm the programming lead of Team 7461. This is a beautiful picture of me right here, and definitely not Abhinav Diddy. It's okay that you're late, we're just getting started. So, the purpose of this lesson, I'm not going to teach you programming today, and if you didn't know how to write a program before, you won't leave this knowing how to write a program. If you want to learn like actual programming, you have to do that on your own, and I'll recommend a good book at the end of the lesson. But this is more to encourage you guys to try out programming, and if you don't end up doing the programming subteam, I want you to communicate with the people who did choose to do the programming subteam. So communication is my end goal. This lesson. So, programming. What is the deal? The first thing I want to start off with is saying that programming languages, they just don't matter at all. So, we use Kotlin, and it's a great language, and I'll go over why it's great in a few minutes. But if you've done Java or Python or C++, you have those same skills that you would learn with Kotlin, and if you're in good programmers aren't specific to any sort of language, so just keep that in mind. That if you don't know Kotlin, but you know other languages, you can pick it up easily. This is the RoboRIO. You put it on the robot. It's just like any other computer. It has the processor like the one in your phone. Things like computer vision can be pretty slow on it, so I'll go over solutions to that later. And it's really reliable. It has built-in stuff to prevent it from exploding, and it's got cool sensor extensions. There's a thing called the NavX that you can place on it, and then it'll get gyroscopes and sensors and a lot of ports, as you can see. So when people are talking about the RIO, they're talking about the big gray brick. You might hear people talking about WPILib. That's the collection of code that lets you talk to the RIO. It also includes some programs that I'll go over, like the Characterization tool, and it's developed by WPI, the college. If you ever hear people talking about IDEs, that's an integrated development environment, and IntelliJ is what we use on this team. Some programmers choose to use Visual Studio Code. That's technically a text editor. But it's almost an IDE. It doesn't really matter. But we specifically like using IntelliJ because it's made by JetBrains, which also develops Kotlin. So the integration is really good. You can copy paste Java code and put it into a Kotlin file, and then it'll convert it automatically. It's there's some cool features with IntelliJ. To collaborate, we use tools like Git and GitHub. So there's a very big distinction here. Git is the software that runs on your computer. It's open source. It's not tied to any sort of company, and it's the program that tracks your versions. And then GitHub is a website that uses Git in order to, and it manages your Git repositories, and it hosts code for free. So there's a lot of competitors to GitHub. There's things like GitLab. We just like using GitHub because it's good. Let's talk about Kotlin and cool things about why we are using Kotlin. But in order to talk about Kotlin, we must talk about Java. So Java was created in 1995. Java is completely different from JavaScript, and you'll annoy me if you mix them up. The syntax is similar to C or C++, and that was one of the reasons why it was popularized. But to understand the main reason it was popularized was to talk about languages at the time when Java was developed, right? So compiled languages like C, right? Computers can't understand your C code or your Java code or your Kotlin code in their raw form. Instead, they're compiled to an executable. So there's that step that you need to do before you run your program. Yeah, object-oriented programming was a big feature of Java. Java has more packages? What do you mean? Than what? So with compiled languages, right, it's compiled to an executable, but you need to have different executables for different types of operating systems and processors, right? The processor in my phone is an ARM processor, and my computer is an AMD processor, and you might have an Intel, AMD, and Intel processors work the same way. And also, you need to have like different compiled versions for Mac or PC or Linux or whatever. So the reason why Java was so cool, I would imagine that Java has more packages than C or C++, but that's more due to its popularity and not caused by its popularity. I would argue that the big thing that made Java so popular was its write once, run anywhere model. So instead of your code compiling to an executable, Java code runs. It's compiled into Java bytecode, which is this little intermediate step between the machine code that your computers can understand and your human readable Java code, right? So humans can't read Java bytecode, but the Java virtual machine can run Java bytecode. And there's actually different implementations of the Java virtual machine on different computers. So I can build a Java project on Windows, get a jar file, right, which is just like a bunch of Java bytecode, and then my friend on a Mac can run that jar file because they have a JVM that's built for a Mac. So there's different implementations of the JVM, and then they all run Java bytecode. So this is why Kotlin is such a cool language, because it also compiles to Java bytecode. So to your Java virtual machine, Java and Kotlin are the same language. And so you can combine both Java and Kotlin into a single project. And so once it a .class file is just Java bytecode. So you can combine both Java and Kotlin. You can use all the libraries that you want on Java with Kotlin, which makes it super fast to learn if you already know Java. And then you can use the cutting edge features of Kotlin in your already existing project. I'm not going to go specifically into the new modern features of Kotlin because since there are people here who don't know how to program, it's just confusing and not really worth the time. So software tools. Even if you're not doing programming, so one thing I want to change on this team this year is whenever we can meet again. There's this notion that programmers are always the ones to configure, can, or characterize the robot, and those don't actually take programming knowledge. So I want you, Max is correct. A jar file is just a bunch of class files, and it's all just Java bytecode. So a lot of times there's a lot of tasks that get put onto the programmers, but you aren't actually programming specific. So that's what we're going to talk about, right? Driver station. Unfortunately, it only runs on Windows, which makes me like super annoyed. It's just the program that drives the robot. You can see a really cool driver station set up in this picture. We end up just using like the computer of the lead programmer or whoever ends up driving the robot this year. So we probably will not have a driver station as cool as this. There's a lot of config tools for each individual hardware and their manufacturer. So here's a screenshot of the SparkMax client. This was the first like programming subteam task that I did. Just like you configure your SparkMaxes. I'll talk about what a SparkMax is a bit later. It's just a type of motor controller. So there's a bunch of these little config programs for your hardware that are just really handy to have installed. This is the characterization tool. It's separate. I think it's technically part of WPILib, but it's It's like a separate program that you can just download. It's a little Python program. So when you're doing programming, right, there's a lot of like little constants that you need, and these constants vary. Constant numbers, I mean, and they vary like depending on the friction of your robot, how much a part weighs, stuff like that. And so, back in the day, you needed to find these constants manually, and now you just run the tool. It's not perfect, and so some tuning has to be done, but it saves like a ton of time when you can get it working and all configured right. So that is a good thing to learn. Let's talk about motors. They go in motion. So here are some motors. The top one is a brushed motor, and the bottom one, the Neo, is a brushless motor. In brushless motors, they're smaller and lighter, and they last longer. They're generally better, but they're also more expensive, and there's some other differences too. But I'm not like a design guy, so I don't really care. Just know that there are two different motor types. From a programming perspective, just know that there are two different motor types, and brushless motors are cooler. So when you're doing any sort of motor control, we need to talk about control systems, right? In an open loop control system, you take an input and do an output. So an example of an open loop control system is the input would be you flip a switch on your controller, and then you do an output of just moving the motors, right? But let's say the left side of your robot has slightly more friction. So as you hit the switch on your controller and it starts zooming, it'll slightly turn. So a closed loop control system, it takes an input and it evaluates like if you're turning based on like either a sensor on the robot or maybe like an encoder value, and then you would adjust. Then you can go have a super straightforward moving robot, and that's not just for driving. It's also say for your shooter if you want to have it go at a really consistent rate. And I'll get back to this in a couple slides about why this is important. So a SparkMax is one of the motor controllers that you'll see. We have like a big bucket of them. They're $75, I think. They control Neos, which are that middle black one. But yeah, the big thing about the SparkMax is that they can control brushless motors, and the other motor controllers can't. There's also Talons and Victors, and there's a lot of different iterations of Talons and Victors that you'll see like if you Google stuff. But the modern ones that we use are Victor SPX and the Talon SRX. I forget what those acronyms stand for. They're both developed by Cross the Road Electronics, which is why I have the CTRE acronym on there. Just Talons are the cool one. They're like almost twice the price, I think. But they can do closed loop control directly on the device. You can take an encoder on your motor. For those who don't know, an encoder is a sensor that measures like how much your motor is turning, right? You can plug that into your motor controller. Yeah, so I think these motor controllers are used in VEX. There's a lot of, if you've done VEX in the past, I think there are some, what's the word, like, some intersection between the parts that, like these. So yeah, Talons, you can do closed loop control directly on your device, so you can get a very accurate, you can get very accurate movements with your Talons. And since Victors are the cheap ones, you can actually use Victors in your code. You can set your Victor to follow your Talon. So like if you need two motors to control a symmetrical, like say shooter, then you can just have your Victor follow your Talon. It'll do it exactly and save some money. So like if you're on design team, know that that's an option. Is what I'm trying to get with this part. Any questions? So there's I really didn't want to open up like IntelliJ or anything today or show actual code, because I think the goal of these is to just get everyone to know this, and not everyone has to do programming, right? So if let me know if you want to do if you want to be on the programming sub team. There's not a lot we can do over the coronavirus vacation besides just learning Kotlin, and that's the big thing. And if you want to learn Kotlin, the best way to learn is a book called Head First Kotlin. I've heard there's a PDF, and I don't know. Yeah, I mean, I could pull up a. There's a cool site. Let me find it. There's a cool site that compares the two. Kotlin versus Java.com. I'm going to put that in the chat. And so that's a cool site that shows Java and Kotlin code side by side. And you can see how Kotlin just generally, if you've done Java, you'll like really, this will convince you. There's a lot of old things in Java that just don't make a lot of sense to do in 2020, and it borrows features from other languages. It's just really cool. There's things like if any of you have done programming and you've heard of null pointer exceptions and you get them a lot, there's a lot of features in Kotlin that prevent that. The stream is delayed a lot, I think. And it's showing up on my chat, and then like I don't know. Do you guys like doing it on Twitch, or would you prefer something like Zoom? Because if we use Twitch, then other people from other teams can come watch, but then there's like a delay and you guys can't talk. And I do like it when you guys can't talk, because you guys all have annoying voices, but yeah, I don't know what you guys want to do. Yeah, so the main homework is, I'll put this on the Discord server soon, or maybe I'll put something on the website, but I want all of you to have the FRC game tools on your computer. Maybe not the driver station if you don't run Windows, but I don't want you to be like, oh hey, I need this Spark Max tuned, and then pass it off to the first programmer you see because they happen to have those tools downloaded, because nobody wants to do your canvas, your can configuration, but I want that to be spread out a lot of the I want that to be a spread out task on the team. Yeah, Zoom can be laggy. If you like wire into Ethernet, I can get pretty good performance on Zoom. I was streaming the AV stuff for my synagogue with holidays lately, and there's like features you can do in Zoom. Like you can enable HD and then get like almost 720p video. There's stuff you can do to make Zoom, to stream on Zoom. Yeah, so Kotlin, I mean, this site doesn't this site isn't meant to present Kotlin in a less confusing way. It's meant to show how a lot of things can be more compact. It won't be confusing if you learn it from a tutorial. A lot of Kotlin, var and val, that's just so in Java the difference, var is just a variable and val is a final variable. So val is just a constant. The Kotlin syntax is more similar to JavaScript, but JavaScript is a scripting language, and it's under the hood, Java and Kotlin are very similar. It's just syntax where JavaScript looks more like Kotlin. There's actually a bunch of languages that you can program your RIO with, but most teams use Java, and because most teams use Java, we can write Kotlin code and just read their example code and convert it. But yeah, you guys are free to leave if you want. Someone asked, why can't you do var x? Var x equals int, you mean? You actually can do semicolons in Kotlin, but semicolons are dumb. So, like, why make them required, you know? You know what? You can't do var x in Kotlin because because of how it does nulls, right? So if you look at the section on nulls, variables, you need to like explicitly declare them to be able to contain nulls. That's part of a null safety thing, right? If you declare var x, and if you haven't done programming, don't worry about what I'm saying. But if you declare var x, then that'll be set to null, right? And that causes the potential for null pointers. Yeah, so if you like semicolons, you can do them in Kotlin. I think I'm going to say on the team this year, when coronavirus is over and we're all programming and happy fun times, I'm going to say no semicolons, unless like you're doing something weird on the same line, but don't do that. No, so you can't do var x in you can't do var x in Kotlin because that would cause the potential for no pointers. You can explicitly set some it'll give you a compile time error because there's actually not a lot of situations in Kotlin programming when you would want to do that, right? You would always want to like set var x equals is 5, right? And then that way there's no possible way that you could get a null pointer exception. Oh, wait. That question mark at the end of your question, Firebolt? Got it. Okay, I thought you just meant that as a question. This is confusing. Yeah, so then you can have your... I don't know if you can have it alone. I think you might still need to explicitly set it to null. But there's not a lot of... But when you do that, you're ruining Kotlin's null safety feature, and so that defeats the purpose. And I think we're getting at the Kotlin technicality, so if you're not interested in that, then you can leave. But, yeah. Any other questions? Yeah, so you would do var x equals 0, and then x would never be equal to null. Yeah, that's the reasoning behind it. Alright, I think I'm gonna end this stream then. I'll give it like 1 more minute because the delay is weird. If anyone's done Python, I'd say the syntax in Kotlin is honestly more similar to Python. But syntax is meaningless. Syntax is something that you can Google in a minute. And let me know your feedback on the Discord if you want to use Zoom or Twitch, or if you want to there's something I didn't cover here that you want to learn about, I don't know. There's a balance for training lightly. We don't want to overwhelm people, and we also don't want to make people but we also still want to train people, and so yes, pod grammar. All right, I'm gonna stop the stream. So yeah, see you Saturday at 6 next week. We're gonna be doing electrical next week.